In this video, we are going to plot another basic parabola, also this time in Desmos. Now, in this case, we have the parabola y equals x squared plus 5x minus 3. And that is a basic parabola. What makes that a basic parabola is the coefficient of the x squared term. Now, what I mean by that is the number that is in front of the x squared term. Now, you don't see a number there. And because you don't see that number there, that automatically means that the coefficient is equal to 1. So in other words, whenever there's a 1 in front of the x squared, then we know that we have a basic parabola. We also have a basic parabola when the number in front of x squared is negative 1. So either 1 or negative 1 in front of the x squared gives us a basic parabola. If we have other numbers in front of x squared, like 2 or 3, or 1/2, or 1/3. Okay, if those numbers happen to be in front of x squared, then it is no longer a basic parabola. And so I'm going to refer to that as a non-basic parabola. But if the number in front of x squared is 1 or negative 1, we have a basic parabola. And that's what we have here. So we're going to find the vertex. Now in this case, we're going to use Desmos to find the vertex for us. And we'll do that by clicking down here. And there it is. Okay, that is the vertex, negative 2.5, comma, negative 9.25. Now, in another video, we'll talk about how to find that number analytically using a formula and then also synthetic substitution. But for now, we're going to, again, just click on that vertex down there, and we see it's negative 2.5, comma, negative 9.25. So we're going to plot that vertex here, negative 2.5, comma, negative 9.25. Okay, and then if we label that, there's our vertex right there. Okay, now using the vertex, I'm going to uncheck the label box there, so we know that that's the vertex. Now, using that vertex and the pattern that we were able to discern in the previous video, what we're going to do is, starting from that vertex, we're going to move to the right 1 unit and to the left 1 unit. Then we're going to move 2 units to the left and right, 3 units to the left and right, 4 units to the left and right, and eventually 5 units to the left and right. And we're going to do that by, first of all, copying and pasting. That's going to give us 5 points to the right of the vertex and 5 points to the left of the vertex. And so we're going to need to paste 10 versions of that vertex in successive entry points here in Desmos. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now to do that, what I'm doing is when I grab the initial vertex, I then type on my keyboard, I hold down the Control key, or if you're using a Macintosh, it would be Command key, and then the letter C. So that copies the thing that I have selected there. And we know it's selected when it's covered in blue. So I've selected that, then I do Control C or Command C, depending on whether I'm using a PC or a Mac. And then to paste it, right, basically what I've done is I hit the Enter key to get a new entry field there on Desmos, and then I go Control V. So I hold down the Control key and the letter V, or Command V if I'm working on a Mac, and that pastes the thing I've copied into the field there on Desmos. Okay, so then what we're going to do with all of these is we're going to go through them and we're going to add 1 and then subtract 1. Now you can see the points that are developing here next to the vertex on the same horizontal level as the vertex in the graph field. Okay, then we're going to add 2 and subtract 2. Then we're going to add 3 and subtract 3. Then we're going to add 4 and subtract 4. Then we'll add 5 and subtract 5. And I know I've got one left, which I'm going to clear. Okay, so that gives us our 10 points, 5 on the right side of the vertex and 5 on the left side of the vertex. You can see them, and they're pretty colored dots here on the same level as the vertex. Okay, so then we're going to go back to each of these points, and where we added 1, we're going to square 1. 1 squared is equal to 1, which we're then going to add to the y-coordinate. And then when we get to 2, we're going to square 2, which gives us 4, which we will then add to the y-coordinate. So we're going to take the square of each of those numbers that we added to the x-coordinate, and then add that square, that result, to the y-coordinate. So 1 squared is 1, so we will add 1 to the y-coordinate. When we do that, the point that was in the horizontal row jumps up onto the parabola. So then when we subtract 1, we're going to square that. Minus 1 squared is also positive 1, so we add 1 to the y-coordinate, and it jumps up onto the parabola. Okay, now in this case we've added 2 to the x-coordinate. 2 squared is 4, so we're going to add 4 to the y-coordinate, and then we'll also add 4 to the y-coordinate when we subtract 2. And notice that those points jump up and onto the basic parabola. Okay, when we added 3, 3 squared is 9, so we're going to add 9 in both of these cases. And you see that those points jump up onto the parabola. When we add 4, 4 squared is 16, so we add 16 here and here. And so those points jumped up onto the parabola. And then finally, when we add 5, we're going to add 25 to the y-coordinate. Now, you don't see that happening because it's happening off the scale here. In order to be able to see those last 2 points, which we've added, we actually have to zoom out. When we zoom out, we should be seeing those 1, 2, 3, 4, 5. There they are right there. So actually, let me see if I can zoom back in and capture all those same points. I can right there. Okay, so there are our points. Right, we have 5 points on the right side of the vertex and 5 points on the left side of the vertex. If we label those last 2, okay, we get those last 2 points. Okay, and we see where they are. So, okay, so that gives us our, and I'm going to zoom out to make it a little bit easier to see possibly here. Okay, and I'm going to label all of the points. And I can do that just by simply clicking the label box on Desmos, including the vertex itself. So we have the vertex, and then we've got 5 points to the right of the vertex and 5 points to the left of the vertex. Hopefully you find this helpful.